Yay!
Yay! Okay, let's do a little bit something different for this example. This is going to be just like the last example, except this time we're not going to require that one of the carts be at rest. So we're going to have an elastic collision, A hitting B, except now it's okay that both of them move. I just happen to put in that B is now moving to the right at 6, and we'll see what happens. I just sort of drew A as going backwards after the collision, but we'll see. Okay, so A and B could be in relative motion. So how are we going to handle this? Because there was no, we set VBI, the initial speed of B, to be 0 last time. So let's see how we're going to handle this. Here's a trick. And this is a neat trick, and it's used all over physics, especially at the higher levels, all the time. Here's the trick. We're going to change our reference frame. So that B is at rest. That's the whole trick. Because it turns out, this was one of Einstein's key points in developing relativity. It turns out that physics doesn't change if you switch to another reference frame, as long as they're moving at constant velocity. So if I switch into B's reference frame, the principles of physics, momentum conservation, energy conservation, all that stuff still holds in the new reference frame. So here's the trick. I'm going to pretend like I'm watching this collision from the point of view of B, or from the point of view of like a train, in this case, a train that's going to go to the right at like 6 meters per second, so that B is just standing still. And we're going to evaluate the collision, and then we're going to transform back. You might think it's sort of cheating, but it's a trick that always works, is that you can transform into a different reference frame that makes the problem easy, solve the problem, and then switch back again. So that's what we're going to do. Okay, so if B is going to the right at 6 meters per second, how do we make B's velocity 0? What you have to do is you have to subtract 6 meters per second from everybody. So VAI is equal to 6 meters per second. VBI is equal to 0. And then in that case, VII is 6. So in that case, now what we can do is go ahead and solve the problem, just using the equations that we had last time. So last time we had that VA final is MA minus MB over the sum times the initial speed. VB final is 2MA over MA plus MB. Okay, so if I use those, the difference of the masses is -4, sum of the masses is +8. So this is going to be minus VA final is -1/2, times the initial speed, which we said is 6 in this frame. So this is going to be a -3. And VB final in this frame is going to be 2 times A, so it's going to be 1/2 times 6, or a +3. Okay, this is still in the frame where B is at rest, right? So we've solved the problem. Now transform back. How do we transform back? We just undo what we did in the first place. The first thing we did was to subtract the speed of B so that it went down to 0. So once we get our answers, now we're going to add that back in. So now, transform back. Which means we're going to add 6 to get back to where we were before. So VA final in the new frame is, if I add 6, I'm going to get a +3. And VB final, if I add 6, is going to be a +9. Okay. So it turned out that looks like I drew it a little bit wrong, right? So VA final actually is going to be going that way at the end. It's just going to be slowed down. Okay, so again, you might be a little skeptical of this trick. Let's verify that this thing actually worked. So let's check. Always a good thing to do. Let's check momentum. Okay, so in this frame, let's see. Initially, I had 2 times 12, and then B was moving, wasn't it? 6 times 6. There we go. So this is going to be 24 and 36. Okay, afterwards, what do I have? I have 2 times 3 plus 6 times 9. What is that? 54 and 6. So both sides are 60. Yep, got it. Let's check kinetic energy, just to make sure. Kinetic energy, 1/2 times 2 times 12 squared, plus 1/2, 6. What was it, 6 squared? Is this 1/2 times 2 times 3 squared, plus 1/2 times 6 times 9 squared. Okay, so let's see, this is 144, and this is going to be 108. So is this the same thing as 9 plus, oh shoot, 81 times 6. What the heck is that? 486 times a half? 243? So 252 on each side, you betcha. Sure enough. So this trick worked. So this changing frames is something that physicists do all the time. You change into something that makes a problem easy, and then you switch back again. So we'll be using this over and over again as we go on.